No, let's use the 81. So this was 3 to the power of 4 equals 81. And then logarithm of base 3 of 81 equals 4. So now from here, what is x and y? X is 81 and y is 4. Now here for that function, they reverse the rows because it's inverse. So it becomes 481. 481. So for every point here, you change the coordinate. The second becomes first, the first becomes second, and you get the points here. And the opposite also is true. So that's why we have this symmetry, line of symmetry. Okay, so what is the domain of a to the power of x? Domain. Domain means the function to be defined. Where can we take, what values of x can we put here? Any value. That's what we started talking at the beginning, that we would like here to be able to put any real number. So here the domain is the whole set of real numbers. The whole set of real numbers is here, right? Where is the range of a of x? Huh? The range of a of x. In other words, what values can a to the power of x assume? Look here. Look here. So only the values can be only from above 0 and to the top, right? So it means the range is every positive number. Every positive. It can never become 0, it can never become negative. Why is that? Because a is greater than 1. So a raised to any power, again we are getting a positive number, just like a. Alright, so the range is from 0 to plus infinity, but 0 is not included. Now, the second here should be very easy. What do we need to do? We just need to swap. The domain becomes range, the range becomes domain. So who wants to try it? Very easy. Very easy. Let me try SHPA. So, what do you need to do? You just have to take here what is written here and put it here. So the domain, the range of logarithm a of x is any real number, or the set of all real numbers. It's a set. The set of all real numbers. What should we put here? Yes. Why? Because we have to take this and put it here. We just swap the two places. Very easy. You don't have even to understand anything. You see, that's the trick sometimes. Now, what is this, guys? These two lines, here is like a small trick. Composition of one of the function and then the inverse. And here also composition, one of the functions and then the inverse. Remember, the inverse of the exponential is the logarithm. What is the inverse of the logarithmic function? The exponential. It's like we have a couple, married couple. And what was that word that means the opposite of the couple? Fiancé. let's suppose. So, I can maybe use you as an example. So I ask, what is the fiancé of this lady? And they point here. And then I say, what is the fiancé of this guy? And they point towards you. Here is the same. What is the inverse of the exponential? Logarithmic. What is the inverse of the logarithmic? The exponential. And it's here down. So first we apply the exponential, and then we apply the logarithmic. Here, the domain is any real number. So if we go from here to here and then back, we come exactly to the same place, x. We start from x and we come to x. And x, because it comes from here, x can be any real number. Now we can put things opposite way. First we apply the logarithmic and then we apply the exponential. So from here we come here and then go back. So we will come to the same place, x, x. But here x needs to be positive. Why? Because the domain of the logarithmic function is from 0 to plus infinity. Guys, does it make sense? This is famous function for Google, Facebook, all these computer companies. This is really function that they use on everyday basis. They talk to each other and many times per day they use that function, believe or not. Not so much this one, and so on. So what happens? When we increase the base, the function becomes to grow slower. But what is here? Do we have a limit, guys? Do we have a limit? If you remember before one slide, what is the range of the logarithmic function? The range of the logarithmic function is the domain of the exponential function. The domain of the exponential function is the whole set of real numbers. So it means that here, this function grows without any limit, but it grows very slowly. You can also combine. From time to time, Google people work with this function, logarithm 2 of logarithm 2 of x. So this function also grows without any limit, but it grows extremely slow. So it's like to ask a turtle to go around the globe. It will go, right? The turtle will. If it has infinite energy, it will go around the globe, but very slow. So this logarithm of logarithm is a very slow function. Like for example, here if you put x 10 billion, you will get maybe a number like 7 or 8. But believe or not, that function has no limit. You can make it as big as you want. Okay, this is from high school. I'm not going to go through that. What is amazing here is that multiplicative operation becomes sum. Division becomes difference. So this really, it's a very tricky business. And raising to an exponent becomes multiplicative. And here, what is this? This is like changing the base. You can take any base and convert to another base. If you don't like the base, you can convert to another base. But need some correction. Okay, let's do some interactive mathematics. Now, who wants to be in charge? I put you in charge because you are maybe future and you make sense and so on, so I put you in charge. Can you somehow organize so we can compute the left number and the right number? What is logarithm base 4 of 2? It's not so difficult here. 4 raised to which power would give us 2? Come here, you can ask anybody to help you, you can do whatever you want. I just need to go and talk to Niall for 1 minute. Come. Come here, yes? Who? Oh, you saw him. What time? Okay, come. I have one private question. Because, no, Does anyone know where is the cheapest place to buy a ticket? Maybe Air Asia or what?
You can buy Bangkok Air.
Yeah, online for sure it's cheaper. But Air Asia or Bangkok? Yes, JC Airline. JC Airline, right? There is such an airline. I've never heard. Maybe it will fall. Right. So guys, let's have some fun. Here, what is the number that we get? If we just concentrate here, we get one number, and here we get another number. But as usual, there is a better way. There are two ways. One is better, another one is slow. Which one is the better way? We have to notice that here is 4 and here is 4. So if the base is the same, we can use this additive multiplicative change. You want to come and put it here, huh? Why not? Who wants to come and put it? Yes, come. Same base. 4, 4. So, we're going to use a rule in the opposite direction, from left to right. No, from right to left. Log 4 of 32 equals log 4. Right, very good. Log 64. So now 4 raised to which power gives us 64. 4 raised to which power gives us 64? 4 multiplied by 4 once 16. Multiplied by 4, it gives us, so you get 3, man, 3. Yeah, but here you just get 3. Why? Because 4 to the power of 3 equals 64. Let's check. 4 multiplied by 4 multiplied by 4. How much is that? Okay. Let's do the next one. It's very good. Now here is what? Here we have the same base 2, but it's subtraction. If we go back, subtraction becomes what? Division. You want to come? No, you know, I am now in a very good mood, so I go and just randomly pick one. Come. Logarithm is very important function in business because it is the inverse of the exponential function. So if you have some mystery about the exponential function, you want to solve that mystery, you use the logarithmic function. Logarithm 2 of 80 minus logarithm 2 of 5. Now the difference becomes what? Becomes division. So 80 Yeah. Let's see, 80 divided by 5. Yes, 16. And yes. Okay. Yes. 4. Now let's do another problem. Okay. Now, one of the logarithm functions, see guys, we have a family of functions. Logarithm base A of x. When we change A from A to A, we get different logarithmic functions. Many, many. But one of them is special. When the base is this famous constant, the Euler constant, or the Napier constant, then, in order to save time, we don't write O and we don't write E. Just say ln of x. ln of x means logarithm with base E. And because this function is very important in finance, what can you think about that function? Also very important. So here, natural logarithm means e to the power of y gives you x. Now, the exponential with base e and the natural logarithm, they are inverse function. They are like a married couple. Married couple, and when we apply the first and then the second, we get 2x. When we apply the second and then the first, we get 2x. Here x is all real numbers, and here x is just the positive. Why? Because the logarithm, look here at the logarithm. It's not defined for any negative or zero values. Now guys, this we are not going to use in this class, so I will go with the speed of light. Okay, so here is a new fun. How can we solve this equation? Is there any way to solve this equation? Obviously, that is not a linear equation. This equation is not also quadratic. Here we have the exponential function, and here we have a constant. What can we do to get rid of the exponential function, for example? Big plus.
Take the right side to b to the power of ln 10.
You mean you concentrate on the right-hand side or on the left-hand side?
Right-hand side.
On the right-hand side. Yes, that is a good idea. If we can represent 10, he says, maybe because you're talking so quietly that I cannot understand. So if we can find 10 as a power of e, maybe, then immediately we can solve the equation. But there is a second way. The second way is maybe a little bit clearer. What if we get rid here of the exponential function? How can we get it? We have a tool. So from here we go there, and then from there we go back. So we can use the inverse function. The inverse function is the logarithmic function. If we apply the logarithmic function to both sides, here we will get rid of the exponential function. So let's write it. I was told that Niall will be for 2 weeks in London.